this is 10.1 scatter plots and correlations. The first thing that we're going to go over is some terminology. You can pause to read, but simple correlation and regression studies is when the researcher collects data on two numerical or quantitative variables to see whether a relationship exists between the variables. The two different types of variables that we have in this situation is independent and dependent. The variable in regression that can be controlled or manipulated is the independent, and the variable that cannot be controlled or manipulated is the dependent.
Some other important terminology include the correlation coefficient, represented by the letter R, computed from the sample data. It measures the strength and direction of a linear relationship between two quantitative variables. A strong positive linear relationship is when one variable increases x, the other variable y increases by the same amount, making the slope always equal to 1. A strong negative linear relationship is when one variable increases while the other variable decreases, making the slope negative.
Construct a scatter plot for the data shown for coffee stores in the United States for a recent year. If a researcher wishes to see whether there is a relationship between the salary of various coffee shops and employment rates, they must select a random sample of coffee shops, determine the salary and employment rates of each company. As you can tell in the right hand shown below, in this example it looks as if a strong positive linear relationship exists between the coffee shop salary and employment rates by each company.
This is the second example for the application for day-to-day life. This topic is in relation to animal science. It is the relationship between the gestation period and the average longevity of a random sample of animals. So if a researcher wanted to study this relationship, they could use this data and plot it on a scatter plot as seen on the right-hand side of this slide. And after plotting it, one can conclude that there's a weak positive linear relationship between these two variables.
The next example I'm going to go over is how to construct a scatter plot for the data shown. So the x-axis would be your hours studied, and statistics exam grade would be your y. The next thing I did was I made a graph with the hours and the grades and plotted each point where it needed to go. So the 0.568 would go on the first line, and as we can see, the trend of the slope is positive because as more hours are spent studying, the better the grade is.
For this example, compute the linear correlation coefficient for the data given for the number of students and the number of books read per student to find the R value. First, find the values of x, y, x squared, and y squared. Then substitute the values in the formula and to solve for R. Pause the video and do this. You should have received that R is approximately 0.293, which indicates a weak positive linear relationship between the number of students and the number of books read per student, as it is closer to 0 than it is to positive 1.
For example 3, we're going to use the R value that we just found to test the significance of the correlation coefficient. Here are your steps. First step, state the hypothesis. H null is P is equal to 0, which is also your claim, and the alternative is P is not equal to 0. Next, you have to find your critical values. Since your degrees of freedom is 3 and your A is 0.1, you just look on the table and find 2.353 as your critical value, but it's positive negative because it's a two-tailed test. Next, you plug your values into the T equation. And lastly, you have to make your decision, which in this case, we're going to fail to reject the null because there's not enough evidence to reject the null.
This is our fourth example where we're going to be testing the significance of the correlation coefficient using the p-value method. Our first step is to state the hypothesis. Our H null is P is equal to 0, and that's our claim, and the H alternative is P is not equal to 0. Next, we're going to find the test value. We have done this in the previous slides, and we have found that T is equal to 0.53. Next is to find the p-value. So I've done so by plugging the values into a calculator, and the calculator steps can be seen on the right side, where we got our p-value to equal 0.6328. Next, we're going to make the decision to either reject or fail to reject the null hypothesis. Because this is a two-tailed problem, we have to multiply the p-value by 2 before comparing it to alpha. Once completed, we could conclude that the p-value is greater than alpha, which means that we have failed to reject the null hypothesis. Finally, we must summarize the results, and because our H null is our claim, we can say that there is not enough evidence to reject the claim.
How can this information be utilized in the video? This can be used to determine how alkaline or acidic the solution tests are on the mung beans. In the video, there are two variables. One is the amount of germinated mung beans that are dependent, while the pH solutions are independent. This is seen in the germination rate because it depends on the pH solution tested within their environment.
A visual representation like a scatter plot will be able to determine a positive, negative, or curvilinear relationship, as well as determine if there is no relationship at all between the variables. Once the visual is complete, one can determine if there are any outliers. The correlation coefficient is able to measure the strength of the linear relationship between two variables. So using this, we'd be able to determine the strength of the relationship between the pH levels of the solution and the germination rates.